Hello everyone, we're going to talk about lesson 5.5 today, properties of logarithms. This is part 1, and in part 2 we're going to talk about change of base. Properties of logarithms are used to solve logarithms and exponential equations. You will not be tested in Algebra 2 on your end of course at the end of the year with logarithms, but it will show up on your ACT. So I like to show my honor students how to use the basic properties so you can be prepared, a little bit better prepared your junior year for your ACT. So let's talk about the product property and how it is different from the quotient property. So if you look, you have a logarithm with base b. And right here we have a product of m times n. Well, sometimes you get stuck when you are trying to solve something and you need to separate the m and the n. If you notice how they're being multiplied, well, since logarithms are exponents, you basically kind of go backwards your exponential properties. So if you have the same base, typically what you do with your exponents is you add them together. So what we're going to do here is if we wanted to separate these, since they're being multiplied, you can go ahead and separate them. Just make sure that you have the logarithm of the same base, but instead of writing them together as a product, you can separate them using addition. It's just, I don't know, it just kind of helps remember the property. So if you multiply the same base, you add your exponents. So if you have a product property, you're going to add the separated logarithms. You can remember the quotient property in the same way. If you see that you have a division situation here where you're dividing m by n, if you were dividing the same base, what you would do is you would subtract the exponents. So to help you remember, if you wanted to separate the division, you can use a logarithm of the same base, separate the m and the n, but you're going to use subtraction to do so. So one more time, product property allows you to separate the m and the n using addition, and the quotient property allows you to separate the numerator and the denominator using subtraction. Now, it works both ways. You can actually go from addition to product and subtraction to division. It just kind of depends on your needs. The last property I want to talk about is the power property, and this one's very popular even in basic equations. All you have to do is recognize the fact that you have a power on a logarithm here. So you're taking log base b of m, but it has to the power of n. What you can do is you can rewrite it in front of the logarithm as a product. So just drag that exponent down to the front of the logarithm and multiply to the logarithm. And once again, if you see that it has a number in front of your logarithm, you can go backwards and you can rewrite that as an exponent. It just depends on your needs. So on these examples, what we're going to do is use a few things that they give us to help us evaluate each expression. So we have to be somewhat clever to do this. It gives us that log base 2 of 3 is equal to 3 over 7. And then it also gives us log base 2 of 7 is approximately 2.807. So I think what we're going to need to do is we're going to need to separate each expression into a log base 2 of 3 or log base 2 of 7. So let's look at this first example here. This looks like I've got the log base 2 of 3 over 7. I don't know 3 over 7, but if I could separate the 3 and the 7, I could finish the problem. So it says, which property can you use to rewrite the expression? Well, since I've got a quotient, what I can do is use the quotient property to separate the 3 and the 7. So I'm going to rewrite this with two separated logarithms, same base as it started with. So I'm going to use base 2. I'm going to write the 3 first, the 7 last, and the quotient property tells us when we separate it, we have to subtract the logarithms. So now you see I have log base 2 of 3, which I can substitute 3 over 7 for. And then I have log base 2 of 7, which can be substituted with 2.807. So I'm going to write this down, 3 over 7 minus 2.807, and we'll just type that in our calculator and see what we get. So after typing it into the calculator, I wound up with negative 2.378. So on the second example, I'll start out with a 21. So what we have to do is we have to think, how can we rewrite 21 to use the 3 and the 7? Well, I know that the log of 21 can be rewritten as log base 2 of 3 times 7. And then we kind of have a property situation where I have a 3 times the 7, which is the product property. And the product property says I can go ahead and separate them as long as I use addition. So if it's product, separate them into the same logarithm and the base, but then I'm going to add them together. So I'm going to write 3 over 7 plus 2.807. And let's type that in our calculator and see what we get. So after typing that one in, I got 3.236, and these are all estimates, but as you can see, it's giving me the ability to do this without having a calculator that calculates logarithms for us. This last one here, what we want to do is we want to rewrite the 49 with a different base, because I can't change 49 into 3 times 7 or any combination thereof, but I can rewrite it with a different base. So what about base 7? So I know that that is 7 squared, and this is the product property. Oh, I said it wrong. That is the power property. So the power property, if you see that you're taking the logarithm of a number or variable, you can take that power and you can bring it into the front. Now, just remember, when you do use that power property, that power has to be affecting everything in the logarithm. So if I had like a situation where it was log base 2 and then I had like 2 times 7 squared, I would need to separate the 2 from the 7 before I use that power property. Because if I move the 2 to the front, that means that the 2 and the 7 are both squared. And that's just not the case. So I only have one thing with a square, so I can rewrite that as twice log base 2 of 7, and let's look back. That is 2.807. So I can say 2 times 2.807, and let's type that in our calculator. And we wind up with 5.614. So the properties give us options, and that's what we need to solve equations sometimes. So to get better at using our properties, we're going to do 2 different things. We're going to start by expanding them, and then we're going to finish by condensing. So this is how to, just kind of some general rules on how to expand your expressions. First thing you want to try to do is separate the numerator and the denominator if you have a quotient situation. If you have products, then you can go ahead and separate them. And then last, you would use that power property. So let's look here. I have a power, I have a product, and I have a quotient. I'm going to tell you right now, ideally what you want to do is separate the numerator from the denominator by using the quotient property. So since this is a natural log, I'm going to use natural log to separate them. Numerator first, and then subtract denominator. So that was just the quotient property. So for us to fully expand this, what I need to do is I need to continue with this first part here. I have a product and I have a power. But if you notice, the 7 only affects the x. So I'm going to highlight base 5, that is to the power of 1. And I have 7 to the, or x to the power of 7. I need to separate the 5 and the x to continue. So I'm going to say the natural log of 5. If it's a product, I'm going to add natural log of x to the power of 7, and I'm just going to drop this down. So now I have one last thing that I need to deal with, this power right here of 7. And then I'm just going to keep everything else the same. Notice 5 does not have a power to it, which is accurate. The 7's going to go into the front. and then this one still remains the same. So this is how you need to correctly evaluate a logarithm that has several different properties. So let's look at the second example. I have a product, and it looks like I need to change that square root into a power. So remember that a square root is to the power of 1/2. So this x is only to the power of 1/2, not the 2. So one more time, we need to separate these two bases before I use the power property. So I'm going to separate the product, the 2, and the x need to be separated using addition. Now that I have them separated, I'm allowed to use this product property. I keep saying product, I meant power. So I have log base 5 of 2 plus 1/2 log base 5 of x. And that's how you expand a logarithm. In the last two examples, we are condensing the logarithms. This is the exact opposite direction of expanding, so naturally you are going to want to go in the opposite step order as we did before. So the first thing that we want to do is we're going to apply the power property. Then we would go ahead and take care of addition, subtraction, typically from left to right, and then use the quotient property if we need to do that. So let's look at question number 1. Do we have any properties? Absolutely. I have a power here in the front of both logarithms. So I'm going to go ahead and bring this 4 up to a power and the 8. So now I have natural log of x to the power of 4 and the natural log of y to the power of 8. I have addition in this problem, and if I'm adding 2 of the same logarithms, I'm able to condense them into one logarithm. So to condense addition, these two are going to wind up being multiplied. So I'm going to take x to the power of 4, and I'm going to multiply that times y to the power of 8. Second example. We have several things going on here. I need to look to see if I have any powers, and I do. I have a power of a 3, and that looks like all I'm going to do on that first step is to move this 3 up here. So now it's going to be 2 to the power of 3. So generally what we're going to do is work left to right. Do you see we've got addition here, which means that when I condense these two, I'm going to multiply the 9 and the 2. Now that doesn't mean 9 times 2 is 18. I can't do that because I have 2 to the power of 3. So the 2 is not really a 2, it's actually 8. If you wanted to, you can go ahead and multiply and say 9 times 8 is 72, but that's kind of not the point right now. I just want to be able to condense these. So one at a time, so I added these two together, and then now this is a subtraction problem, which means that I'm going to write 9 times 2 to the power of 3 on the numerator, and then I'm going to write 3 as the denominator. And this is successfully condensed. Like I said before, if you need to, especially on a multiple choice test, if all of those numbers are evaluated or simplified, you can go ahead and do so. Just let me know if you've got any questions, but that's it for properties of logarithms.